Okay, we're gonna look at something called Pascal's triangle, and we're gonna relate that to combinations. You'll see what that is in a second. So what is Pascal's triangle? It's basically a triangle of numbers, and it's defined as a bunch of numbers where, there's a pattern to the numbers. And the pattern, if you can see the pattern, try and guess what line is next. If you pause the video, take a look at that. And when you come back, you'll see the following. It's 1, 8, 28, 56, 70, 56. And where did these numbers come from? Well, here's the pattern. Okay, so 1 plus 1 is equal to 2. You basically put a 1 and a 1 on the outside, and then you derive it, the inner numbers, by adding these terms. See, so once I have 4 and 1, I know that this middle number is 5. 4 plus 1. 5 plus 10 comes from 15. 35 and 21 make 56. That's where 56 comes from. Okay, so essentially if you wanted to derive it, you just put 1s on the outside. See what number's in here? 2. Put another 1 out there. 3, 3. 1, 4, 6, 4, etc. 1. Of course, I ran out of space, but you get the gist of it. Here's another pattern. If I add up all these numbers, these diagonals, I get this number right here. If I add up this number, these diagonals, I get this number right there. If I add up all these numbers, I get this number, number 8, right there. Okay, now we're going to link Pascal's triangle. Now that we know what Pascal's triangle is, we're going to link that to combinations. And essentially, these values here, that's equal to a 1, right? If I have 0, and I have 0 ways to choose them, there's only one way to choose nothing. If I have 1 and I choose none, there's only one way to do that. If I have 1 and I choose 1, there's only one way to do that. If I have 2 and I choose nothing, basically choosing nothing, there's only one way to do that. If I'm choosing everything, there's only one way to do that, right? And essentially, if I choose 2, if I have 2 objects and I have one way to choose it, well, there's only 2 ways to choose it, and that comes from there. 3 choose 1, well, there's only 3 ways to do that. And if I'm choosing only one object, well, there's only the number of objects, ways to do that. So that's a weird way to say it, right? If I have 1 out of 6 items, I have 6 ways to choose it, 6 items to choose from. So 6 ways, etc. And if I'm choosing 1, if I'm choosing everything except 1, well, I'm not including one of them, right? So there's 3 ways to do that. If I have 4 and I'm picking 3, well, I'm excluding 1 of the 4, right? So there's 4 ways to exclude that one item. So it's almost the exact same, right? So choosing, the number of ways to choose an item is the same as the number of ways to exclude an item, right? You can think of, if I'm choosing all 5 out of 6, well, there's 6 items to exclude, and there's that many ways to do it. And then this just works out to 4 choose 2, well, there's 6 ways to do that. Okay, and that comes from there, right? 5 choose 2, that's going to be 10. Now it's not so obvious here. 6 choose 4, that's also equal to 10, right? So you can see that Pascal's triangle is, if you really want a quick way to solve a combinations problem, right? If I have Pascal's triangle ready, 1, 2, 1. If I say, what's 7 choose 3? Well, a real quick way is just to 1, 4, 6, 1. Sorry, 4, 1. And I'm on, basically if I get to 7. Let's see. I have it here, but I can just say, see, this is 1, 5, 6, 7. Oops, it doesn't even matter, right? I can just fill it up from this end. 10, 10. This would be 5. 5 plus 10 is 15. 6 plus 7 is 21. And 10 plus 10 is 20. 15 plus is 35. So this is 7, choose 0. 7, choose 1. 7, choose 2. And 7, choose 3, which is equal to 35. I mean, I think it's quick. You could also just do 7 factorial over 7 minus 3 factorial over 3 factorial, which is essentially equal to 7 times 6 times 5 times 4, factorial. We can go like that. And then that's 7 minus 3 is 4 factorial times 3 factorial, which is 6, which is 7 times 5, which is equal to 35. But there's many ways to solve the same thing. Here are more patterns. Okay, we call that diagonal R0, and that's actually the same thing as that. Okay, that's diagonal 2, R equals 2. Okay, and what does that mean? It's like C choose 2, right? C choose 2. And this is equal to C choose 5, R choose 5, row 5, or R choose 5. And you'll see what I'm talking about in a second. So that's R1, right? We're choosing. So for N is 1, N is 2, N is 3, but R is 1. That's why we call it R1. Now, if I'm adding all the ways I can choose one item from multiple items, like if I have one item, I choose one item. If I have 2 items, I choose 1 item. 3 items, I choose 3 items. Essentially, that's equal to the same thing as saying 6 choose 2. If I have 6 terms, that's the same thing as saying 7 choose 4 if I add them up. Okay. Let's see. Did I specify? I just wanted to. I'll go back to the previous slide in a second, right? So let's go back to the previous slide and take a look and kind of prove it too. Whoops. So okay. So calculate the sum of the first 5 terms of row 6. R choose 6. So that's 0, 1, 2, 3, 4, 5, 6. So the first 5 items, 1, 2, 3, 4, 5. So find the sum is going to be equal to 330. Okay. And just to verify, you can do that math. It's the same thing as choosing, look, when R is 6, right? The first 5 terms. So if I have 6 items, I choose 6. I have 7 items, I choose 6. 8 items, I choose 6. 9 items, I choose 6. 10 items, I choose 6. The answer is 11, choose 7, which is equal to 330. Which is the same thing. If I drew Pascal's triangle, I could just find it that way instead of doing the calculation. Okay, you'll find this useful later on. It's the same thing right there. Okay, next question. Example 2. Bill rides his bike to school and travels 6 blocks west and 4 blocks south. Use 2 methods to determine the number of different routes Bill can take to school if he travels only north and west. So use 2 methods. Don't worry about use 2 methods for now. We'll use one method, method 1. So in total, I have 10 blocks to cross. If I choose westbound block first, I have 10 choose 6 choices. After I choose my 6 blocks, I will select 4 remaining blocks to go south. So it's 10 choose 6 multiplied by 4 choose 4. Now, next example, we have routes on a grid. So we have our starting point right there. Now the reason I have a triangle is I'm going to use Pascal's triangle right here. So when I'm right there, I have one way to get from here to here. And when I'm here, I have one way to get to there. Now from here, there's only one way to get here, etc., etc. There's only one way to get here, right? From over here, etc., etc. But when I'm here, it's seven ways to get here, and we'll see why. Okay, so if my starting point's here, I only have one way to get there, right? Etc., etc. If I have, there's only one way to get here, I go here, and then here, and then here, and then here. So it's kind of like Pascal's triangle. But how many ways are there to get here? Well, I have one this way, and I have this way to get here. So that's a total of 2 possible ways. Now, to get here, well, I can get here from either here or from here. Now, there is only one way to get here, but there's 2 ways to get here. So total, there's 3 ways to get here. I have to add the number of ways there are to get here in the first place, and the number of ways to get here, which is 2, so that's 3. Same thing with this. I can come to this point from here, and there's 2 ways to do that, because I have 2 ways to get to this, and 1 way from here, so that's 3 ways. And we carry on, right? If I was to get here, that's 1 plus 3, that's 1 plus 5, etc. here. And you can kind of see now the pattern with the next one, right? How many ways are there to get to this point? Well, I can get to this point from here. There's 3 ways to do that, and 3 ways to get to this point. So then total, there's 6 ways to get here, etc., etc. And you can see Pascal's triangle playing out, at which point I have 210 ways to get to this point right here. Okay, another way to do something is to use Binomial Theorem. So this should have been coming up last, but I'll just show you this in a second. Whoops. We have x plus y cubed. How do we do that? We expand it, x plus y, multiplied by each other 3 times. Then we expand this here. That comes from there. And then we multiply, each term. We distribute this here, we distribute that there, we distribute that there. And we collect like terms. I'm not going to do it. That's only one of those. X squared y, there's that. XY squared, there's that. And then y cubed, there's only 1. And that gets our final answer there. So we could use Pascal's triangle to do this as well. So if we look at that, x squared, we have x squared plus 2xy plus y squared. But how do you do x plus 7 squared, right? Are you going to expand this 7 times and do that math and collect like terms 7 times downwards? It turns out there's a pattern. And if you noticed, it has to do with Pascal's triangle. If you look at this, right? If you look at x and xy, there's a pattern, but there's also a pattern in the coefficients. And that has to do with Pascal's triangle. 1, 2, 1. 1, 3, 3, 1. 1, 3, 3, 1. And it turns out there's a pattern. So if we did this, this is my coefficients. This happens to be my coefficients for when I expand this out. 1, 7, 21, 35, 35, 21, 7, 1. So let's write it all out. If you see, you can write out the coefficients. 1, 1, 7, 7, 21, 21, 35, 35, etc., etc. Now, what about these things? Well, it starts with x7, x6, x5, x4, x3, x2, x1, x0. x0 is just 1, by the way. So is y0. y0, y1, and then the y keeps getting stronger. y4, y5, y to the 6, y to the 7. And that's basically your expanded out answer. You can use binomial theorem to expand any power of a binomial expression. So I could do this to any n, right? So what's the next term? 1, 8, 28, 56, 70, 70. No, 56. This would be 28, 8, 1. This would be 1, 9, 1, 9. The next line would be, what's 8 plus 28? 36. This would be 84, if I'm not mistaken. I think I'm right. 76 plus 50, 126, I believe. 126, 84, 36, 9, and 1. So if I said, what's x plus y to the power of 9, well, that's just equal to 1, x9, y0 plus 9, x8, y1 plus 36. I'm getting this from here, right? 36, x to the 7, y square plus 84x, oops, not plus, but just x to the 6, y cube, etc., etc. You can finish it on your own and forward through, or you could just continue to watch. It's up to you. 5 to the power of 4 plus 126 xy plus 84. If you want to go faster, xy plus 36 xy plus 9xy plus 1xy, and then you just go 5, 4, 3 for the x, 2 for the x, 1 for the x, 0 for the x. And for the y, you just increase it. 5, 6, 7, 8, and 9. Okay, that's basically it. Okay, here's a general term. The general term is C, n choose 0, 1, 2, 3, etc. And then we start with n, then we go n minus 1 until we get to 0. Then we start from 0 to 1 to 2 and keep increasing until we get to n. And these are your homework questions, page 126. That's the end of this video.